morning and welcome to Wednesday's maths lesson. Now, as it's the first day back, I thought it would be good to practice some basic skills, some basic multiplication skills, and area and perimeter is a really good topic to practice those skills. So let's take a look at this rectangle. First of all, what makes this a rectangle? Why don't you stop the video and write down 3 things that you think makes this a rectangle? Well, first of all, it's a quadrilateral, so it has 4 sides. It also has 2 pairs of parallel sides, and the opposite sides are the same length. It also has 4 interior angles of 90 degrees. So let's have a look at this rectangle. The perimeter, first of all. Imagine this maybe is a field. Part of a field is going to be marked out as a sports field. So someone needs to come along and mark out the edge of the football pitch or the hockey pitch. And the distance all the way round the sports field is called the perimeter. This can be shortened to P. P equals perimeter. We could also use letters to label the length. So L is the length and W is the width of the rectangle. So let's write some measurements on. Should we imagine that this side is 37 metres and this side is 9 metres. Now, if I wanted to work out the perimeter, the distance all the way round the edge of this rectangle, I've got several options. I could add 37 metres to 9 metres, which would be 37 and 9. If that length is 37, this length must be 37 and this length must be 9. So I need to add another 37 metres and another 9 metres. That would be one way of finding out the perimeter. I could, of course, do 2 lots of 37 metres and add them to 2 lots of 9 metres. That would be another way of working it out. Or I could do 2 lots of 37 metres plus 9 metres. Any of these methods will give you the perimeter of that rectangle. So, if you'd like to stop the video, I've got 2 little challenges for you. First of all, can you work out the perimeter of this rectangle? And secondly, as a bit of a challenge, using the letters L, W and P, could you write an algebraic expression that would show the perimeter of the rectangle? Give it a go. How did you get on? Well, any of these calculations would tell you that the perimeter of this rectangle is 92 metres. If you had a go at the challenge, you can just substitute these measurements for the letter by them. So this would look like L plus W plus L plus W. This one would look like 2L plus 2W, and the bottom one would be 2 lots of L plus W. Now it's time for you to do a little bit of work. So at the top we have 3 rectangles. I would like you to work out the perimeter of these rectangles, and if you complete that, you could go on to the challenge. Here we have a rectangle and I've told you the perimeter. What I would like you to do is to try and work out what the sides could measure, and there will be definitely more than one answer for this. Just remember that this side and this side must be the same length, and this side and this side must be the same length. So off you go and give this little workout a try. So, how did you get on? Well, this rectangle has a perimeter of 42 metres. This perimeter here would be 62 metres. And the final rectangle has a perimeter of 38 metres. Wonder how you got on with the challenge. Now, to solve this final problem, I'm just going to pick some very easy numbers to start with. So I'm going to suggest that the width could be 10 centimetres, and therefore this side must be 10 as well. So I've got 10 and 10 there, which is 20. So if I do 90, take away 20, I need to split 70 centimetres between this length and this length. So I know that 70 divided by 2 is 35 centimetres and 35 centimetres. You might have a different answer, but as long as these two sides are the same length and these two sides are the same length, and these four measurements add up to 90, then it is a potential answer for this problem. Now, what if you're told the perimeter of a rectangle and the length of one side? How would you calculate the width? Well, let's write in what we know. If that side's 55 metres, then this side must also be 55 metres. So first of all, we could add these two edges together, which would equal 110 metres. So I now know that the total perimeter, take away these two sides, would tell me these two sides. So 134 subtract 110 would equal 24 metres. So these two sides must equal 24 metres. So if I then divide 24 metres between 2, that tells me that the width of this rectangle must be 12 metres. Now have a go at solving the missing sides on the rectangles on the next sheet. If you are struggling a little bit, you can always come back to this part of the video and work through this example again. So what I need to know here is the length of this rectangle, the width of that rectangle and the length of that one. Now if you finish, this is a really tricky challenge, can you write an algebraic expression that's using L, W and P to show how you calculated the width of rectangle B? Stop the video and have a go at these problems. So, how did you get on? Well, I've calculated that the missing length on this side is 27 metres. The missing width on triangle B is 23 metres. And the missing length on rectangle C is 14.39 metres. The challenge. So in triangle B, you're missing the width. So to calculate the width, you would have taken the perimeter and you would have subtracted 2 lots of the length. And then when you got your answer, you would have divided it by 2. That was a tricky challenge there. So we've had a look at perimeter. Now let's have a look at area. Now the area of a shape is the amount of space it takes up. So everything inside it. And as you'll probably remember, to calculate the area, which can be abbreviated to A, you need to multiply the length by the width. So in this case, the area would equal 17 metres times 9 metres. Stop the video and see if you can work out the area of this shape and have a think about the units you are going to use. If you can't do this sum in your head, you can always set it out as a long multiplication. Okay, how did you get on? Let's go through the long multiplication. 7 times 9 is 63. 1 lot of 9 is 9, plus 6 is 15. So it's 153 metres times metres, and metres times metres is metres squared. And that will tell us the area of this rectangle. Using that sum as guidance, can you work out the areas of these 3 rectangles? And if you finish, challenge yourself to write an algebraic expression to calculate the area. So that's an expression that would use the letters A, L and W. How did you get on? Well, the first rectangle has an area of 11 times 12 metres squared, which is 132 metres squared. The second rectangle has an area of 37 times 12, which is 444, all the fours, metres squared. And the third rectangle has an area of 41.25 metres squared. The algebraic expression would be that area equals length times width. But when we write algebraic expressions, to avoid the multiplication sign becoming confused with the letters, don't usually write it. So it's taken as read that if 2 letters are together, that means you would multiply them. Now here we have a slightly different problem. We have a rectangle and we're told that the area is 100 metres squared, but we don't know the length of the sides. So stop the video and see if you can work out what these sides could be. There's more than one answer. And a big hint is that you are looking for factors of 100. That's 2 numbers that multiply together to make 100. If you think you've found them all, do this little challenge here. What if the sides were measured to the nearest half metre? What if the sides weren't a whole number? Can you come up with a possibility for the width and the length? Have a little go. Well, I decided to work systematically to find factors of 100. And as you can see, I started with the easy one. 1 times 100, 2 times 50, 4 times 25 and 5 times 20. Now, 10 and 10 are also factors of 100. However, have a think, why can't the sides of this rectangle measure 10 times 10? That's because this is not a square. If it was a square, the sides would be the same length, and they're obviously not the same length. The challenge, what if the sides were measured to the nearest ½ metre? Well, I came up with this possibility, which is 2.5 width times 40 length, which would give us an area of 100 metres squared. And one more problem to do with area. If you were told that the area of this rectangle is 180 metres squared, and you know that the length of one side is 20, how would you work out the missing width? Well, I know that length times width is area, so I could rearrange that to do area divided by the length equals the width, which would be 180 divided by 20. I know that 18 divided by 2 equals 9. So the missing width is 9 metres. It's all about using your multiplication and division facts. Have a go at finding the missing length on this rectangle and the missing width on this rectangle. Stop the video while you have a go. How did you do? Well, to find this out, we need to do area 360 divided by 4, which equals 90 metres. And here we need to do 20 divided by 8, which equals 2.5 metres. Okay, now over on Google Classroom you'll find 3 different worksheets. And by doing these you'll be able to practice the skills that you've revised today. Obviously if you get stuck on the worksheets you could always go back and watch little bits of the video. And the worksheet starts as spicy, the next one is hot, and the third one is very hot. So have a look at them and decide where you would like to start your practice for today.